Good evening. Thank you very much for joining us here tonight. We have a good turnout for this. My name is Larry Thiel. I'm the director of the Global Affairs Center. Tonight's our topic is biofuels and climate change. Many members of the audience are participating in a series of weekly discussions about major foreign policy issues facing the United States. And this week the topic is climate change. So this is very timely. Actually, we made it very timely. We will be talking about one alternative, particularly to carbon-based energy biofuels in the context of addressing the issues of climate change. So we're trying to bring the two together that way here. Chip Dodd, who teaches geography here, sits in the middle of the table. He does not teach geology, as I incorrectly, some damn fool, incorrectly put in in a couple of the announcements. But as I pointed out, it could have been worse. I could have called him a political scientist, but Chip is in fact a geographer. He's going to be moderating the discussion. Chip teaches here at the college. Has been here quite a few years. He teaches geopolitics. He also teaches international studies. We team teach a class together on globalization in the fall, and Chip then teaches a class as well in the winter, or in the spring, excuse me, in the spring on
International political economy.
Right.
We have some students from that class in here.
Yeah, and there's some students from the classroom here. Chip specializes in geopolitics. He's a strong interest in anything related to geography, including the climate. So he does pay attention to the issues of climate change. In the past, Chip has worked in the Bureau of Intelligence and Research in the Department of State, where he specialized in water and energy resource issues. Let's see if I'm forgetting anything. Oh yeah, Chip studied at University of California, Berkeley. He studied political economy. I knew the politics were somewhere in there. And he has a master's degree from the University of Washington in geography. Chip will introduce the other panelists, and when we get to the questions and answers about 8 o'clock, you can ask your question directly, or you can scribble your question on the card that's in your program, and we will try our best to get all the questions posed. So without further ado, I'm going to turn it over to Chip.
Thank you, Larry, and welcome to Earth Week at Shoreline. Larry didn't mention this, but we're in the midst of Earth Week. Tomorrow is Earth Day, and this coincides, the great discussions that many people are part of here coincides right, or dovetails right in with Earth Week. So this is also an Earth Week event. And I'm honored to be joined by two people who are not only very knowledgeable about topics relating to the environment, but specifically to biofuels, and are very active in the public policy process. They feel passionate about their work, and I think that'll soon be apparent. We have with us Evan Heinrich, a research assistant with Matrix Genetics, a Seattle company that develops algal products for the fuel, feed, and human health industries. His current focus is on production, process engineering, lab automation, and computational biology tools. He will explain all of this in more detail in presumably a few minutes. Evan has a master's degree from the University of Washington, where he pursued research on biofuel feedstocks, and he's also an alum of Shoreline's biotechnology program. So this is something of a homecoming. Brian Young is Director of Economic Development for the Clean Technology Sector Initiative, and he is the clean technology lead for Governor Inslee. In that role, he is the point of contact for clean technology companies, and he'll be explaining all of that in his remarks tonight. Prior to joining, prior to joining the Commerce Department, Brian worked in a variety of clean tech industries, including Imperium Renewables, the largest independent biodiesel producer in the United States. And he also has been a consultant to clean technology companies, helped to develop the Washington Clean Energy Leadership Council, and has worked internationally on sustainability and carbon issues. Brian graduated from Georgetown University's School of Foreign Service with a degree in science, technology, and international affairs. And for more information about Evan and Brian, please consult the program and the Global Affairs Center website here at Shoreline. So the mission profile or format tonight is we will begin with brief remarks by Evan and Brian about the work they have been doing. And in fact, Evan, if I'm not mistaken, has a PowerPoint to share with us. And their remarks are going to be followed by a discussion among panel members. So I hope to get that started with a few questions. And then we're going to open up the conversation to you all. So without further ado, why don't we get started?
Okay. So I'll start and I'll show a PowerPoint in a second. Just to give you a real general background. So right now I work at a company that uses algae to try and produce valuable products, originally biofuel, but now other products. Previous to that, I was at UW researching how to essentially grow poplar trees faster and try and use that for a feedstock for biofuel. And that was something that was funded by a big research grant, but the end idea was to create fuel for jet fuel. So interesting stuff. But one thing that has affected how I think about all this is I actually originally started a small software company. And so I think of where biofuel and biotech can go in terms of where software is now. And I'll speak to that in a bit. So starting off on this PowerPoint, what is biofuel? And so when I think about it, this is a very general definition. Fuel that basically uses some organism as part of the process. It can be the part that provides the feedstock, the thing that gets digested and changed into the fuel, or it can do that conversion process. So an example of kind of some traditional biofuel would be sugarcane and corn. That's converted by fermentation into ethanol, alcohol. And then you also can do oils, soy, vegetable, a lot of different types, and that can go into things like biodiesel. Something that's a little bit different is you can make methane gas from solid or liquid waste, which is a pretty stinky proposition, but useful for certain places. Now, what does it actually look like? Because I know we talk about this kind of biofuel and it's out there, and what does it look like? So on, let's see, your left, you have these photobioreactors, and that is part of my office. This is, it glows green. That's what it looks like. And this is where algae is growing. Now, growing it is only a small part of the process. You then have to somehow get it out of those reactors and into a very concentrated form so that you can then put it in something that's going to heat it up to a really high temperature and really high pressure and pull out oil, gas, and different components. So, the growing part is actually just a small part, and then something that's really hard, you'd think would be simple, is actually getting the water out of that whole mess. Let's see. Oops, did I go one too many? Yeah. So some things generally that we've learned, we being kind of a scientific community over the past 20, 30 years, is that growing crops for just the purpose of biofuel is very expensive. You're taking land away from something else usually to grow biofuel. And so, this is when people started to think, well, maybe we can use waste, because that actually you might get paid to use waste to create energy. So that's a good idea. Now, the problem is if that waste is somewhere far away from where you want to process it, then you actually have to use energy to get it to the place where you can convert it back to energy, so it doesn't totally make sense all the time. So that's when more academic research started to focus on decentralized or on-site processing, ways that you can do these things in smaller amounts so that you don't need to move it very far. And then the last part, like I mentioned, is dewatering. Just trying to separate algae from water is surprisingly difficult when you want to do it cheaply. So in terms of where things are moving and what's possibly a next generation, things that I don't actually work with right now, but I think are really exciting, are what I would call harvestless technologies. Situations where you're using microbes to directly convert waste into electrical energy. And it's very exciting, but it's never been shown to work at scale yet, which is the challenge with a lot of this stuff. It works great at the lab when it's like that big, but then when you say, okay, would it power X number of houses? It's like, oh, okay, how does that actually work? And then something that's interesting that I've also seen recently is these decentralized waste to energy schemes, or even waste to other types of products. I know there's a group over in Redmond that is doing converting food waste, from PCC or other markets or large, food producers or grocers, converting that to a fertilizer pretty much on site. So they have, relatively small machines that are, maybe the size of, I don't know what you'd put it, a few porta potties or something, not too big to do that. And that's, I think a viable solution. I get one more. Okay. In terms of some of the numbers, trying to figure out what is competitive and what isn't. This comes from, I should have put a line on here, coming from an International Atomic Energy Agency report. And basically what it showed is in Brazil, you can be cost competitive when you create ethanol, about 40 to 50 a barrel, which is more or less where we're at. I think oil is at like 41 today. Now in the US, that's not the same. It's competitive at a much higher cost. If you want to use wood waste, which here, you have a couple of large timber companies, that would be of interest, but it's quite expensive. And that was, something that we found at UW when I was doing research there. So some of the big barriers to think about are you trading, this land that you're going to use from something you might like food, towards biofuel? Or are you able to do this in a way that doesn't make it a zero-sum game? And then also, what about the increased water or nutrient demands if you're growing this just for fuel? So it's a few things to think about. I'll leave it there. So I'll talk for just another few seconds about what I see as some opportunities going forward. My company and my own interests really look at not necessarily the larger process, but the small actual genetic engineering, and what can we do to engineer these organisms to be more productive. And so one of the big challenges there is that we don't yet have a computer model where we can say, this, if we make this change here, it's going to do X, Y, or Z. We can't do that. And so even though you might have read in the news about something called CRISPR, which allows biologists to make a lot of changes to a genome, they don't know what it's going to do necessarily. And that's kind of a challenge when whether it's for us on the biofuel side or for those at like the Hutch doing cancer research. If you can't have a model that predicts stuff, it means that you have to do a lot of work in the lab that may or may not turn out. So that's the first problem. Now the second problem is producing a lot of algae or cells at low cost. And this is a little bit of what I do now, where just creating a process where you can use materials that are relatively cheap but can be used over a long period of time. You'd think it would be simple since we've been making beer and yogurt and other things that rely on organisms for a really long time, but it's not. So one of the things that I think might change the way business is done going forward is using something that software has done in order to scale, which is instead of having all these companies do what you call vertically integrated. So they're making their own cell culture, machinery. They're making doing their own molecular engineering. They're doing everything themselves. In software, we don't do that anymore, right? You have Amazon provides all of your storage and computing power so that a small startup with 2 people can say, okay, I'll pay you, $20 a month, and then I'll focus just on making this cool app that someone might buy. So it doesn't take them millions of dollars to get started. They can just start in their garage. Biofuel doesn't start in a garage. And so I think if you start to see that same sort of dynamic where you have companies taking a slice and saying, I'm going to be really good at predictive modeling, or I'm going to be really good at growing cells, then that small group at the top can say, okay, I'm going to outsource this little bit to you and this little bit to you. And so now you can have more people trying different ideas, and that might help us go a little bit faster. Let's see. And the last thing I would say is that we're lucky to be here in Seattle in terms of you have a couple of folks who were in the software wave, like the Gates and the Allens, who are very much into cells and how cells work and what can we do with them. The Allen Institute for Brain Science and Cell Science is a huge boon to research in this area. So hopefully that can also, jumpstart a cycle of companies that are successful in, biological research, and then, their founders become the investors of the next generation. And I'll leave it there and see what the government side has to say about things.
All right. Welcome. Thanks for coming. As it was mentioned, I'm Brian Young. I am the governor's clean tech sector lead. I work under the at the Department of Commerce for the director there, Brian Bonlander, and work very closely with the governor's staff and the governor on all issues clean tech. So clean tech is more than just biofuels, obviously, and it's more than just energy. It's clean technology. What is that umbrella? It's a big umbrella. You can fit lots under it. My general definition, the way I look at it, is you've got clean energy and all that entails, which you probably understand. And then you've got what I call the environmental side, which is remediation, wastewater, bioproducts, the other side of clean tech that has energy implications and carbon implications, but and is basically looking at either cleaning things up or doing standard processes better in more clean ways. So try to focus on all of that. As you can imagine, it is a big area, and the state's fairly large, and so it's hard to get your head around everything at once. So a lot of it is deciding what the focus areas are going to be for the next month, the next year, and whatnot. So, but I am very much the industry rep on the government side. What I'm going to talk about real quick is just the program that Governor Inslee put together. As an introduction, they asked me to talk about the sector lead program, and then as we get into the next round, we can talk biofuels. So, as mentioned before, my background when I got out here to Seattle, I was the second employee. It was at the time Seattle Biodiesel became Imperium Renewables. I was on that roller coaster ride. Anybody there? Anybody 2004, 2005, 6 involved in this? And there were lots of discussions up here north, and sustainability is always a topic. So it's biofuels are very kind of close to my heart. It's how I got my start, and I love to talk about it. So and you've got to. You're really the microphone. Okay. Don't want to do that. Better? All right. Don't rub the microphone. So very close to my heart, and I love talking about it. You've got a good panel here, I think. Can talk very much about the future of what's going on. I've got a very good grounding in what's happened in the past and where we are, and the kind of very big biofuels that are made today and how we're using them in the state. But real quick, jump into my job and what the role is. Just when Governor Inslee came into the office, one of his first initiatives was this, what's called the Sector Lead program. So when you look at economic development, there's a lot of different ways to do it, and one of the ways that a lot of people are focusing on these days is what you'd call sector-based or cluster-based economic development. So taking a look at, in this case, your state and saying, what are those? There's economic development in all sorts of fields, as you can imagine, but there are certain fields, and you can imagine what they are in the state, that have a special relevance to the state, and in the context of this program is ones that have disproportionate impact on jobs and what's called GBI, gross business income, but the amount of economic income generated by the sectors. So we looked at that, Governor Inslee and his team looked at that and designated originally 7 sectors of the Washington economy that deserved special attention. Aerospace, surprise, surprise. Internet communication technologies, surprise, surprise. Life sciences, global health, agriculture, defense, military, maritime, and clean technology. So there's 7 original sector lead positions developed within the Department of Commerce. They're all filled currently, and I was the first person to hold the clean technology one. I was hired in November of 2014, so just over a year in the position. Most of us came out of private industry, some with some political background, but primarily private industry, and our role is really to act as that go-between between government and industry. We've got an industry perspective, most of us coming out of industry. We also have lots of policy experience in our industry work. So theoretically, we're there to help communicate to the business community what the government's trying to do, hoping to do, what the purposes of their actions are, as well as be able to go out into the sector of the industry that we're related to, and be able to bring back to government ideas from the private sector of why things aren't working or how things could work better, how we could design policy to be more effective and whatnot. So there are not a lot of folks above me. There's not a lot of folks below me. All of us are kind of independent operators out there, and I like to say we are the spark that lights the fire. There's not a lot. I don't have a big staff to do things, but I have lots of connections. I know a good deal about the clean tech sector in particular in this state, and so a lot of what I do is try to bring together different entities to work together to create economic development in the state. One way I look at my role that I think might be some people confused, I'm a clean tech guy, I love clean energy and all that, but my job is not to try to get more green electrons onto our grid, to get more biofuel into our fuel, like more biofuel into our fuel system. I want all that to happen and whatnot, but my job is economic development. It's really to try to help the companies that create the turbines or the solar panels that create that renewable energy, or help the companies that want to create a biodiesel refinery or biofuel refinery, help them establish. So it's really an economic development look at clean tech sector. There's policy people and whatnot that I work with, but are more directly responsible for the true policy side of it. So you can think of us as that economic development side of it. So within the clean tech sector and my world, what are the focus areas in this state, especially where are those areas that we have a very strong cluster of industry that sets us apart from other states, or really is world leading, or we have special capabilities in the state. So I do a lot of focus. Again, I focus on everybody. We have folks doing all sorts of things, and I'm try to help everybody. But if you talk about what a lot of the drivers are, where the feds are investing in us in a big way, where we're seeing some companies that have some real potential on the outside. Kind of three areas, and there are three areas that have been a focus area in the state for a fairly long time. So energy efficiency in the built environment. We literally in the state have been the leaders in energy efficiency since the 70s. I mean, there's nobody in the country that does energy efficiency better than Washington State, which is very much a feather in our hat because we have the cheapest electricity in the states too. So the fact that in the 70s we were going after energy efficiency is very impressive, because a lot of folks are just catching up now, and we weren't driven necessarily by the price as much as by the need and the desire to have energy, more efficient uses of our energy. So we've set the standard in that, and from that's developed not just an energy efficiency policy and companies that work towards energy efficiency, but we now have a very strong cluster of folks that design the most efficient buildings in the world, build the most efficient buildings in the world. I mean, the Bullitt Center, you can imagine the Stan Price over at NEEC and whatnot. We have world leaders, thought leaders in this space. So that's one area, energy efficiency, the built environment, the building envelope. Second area is grid. Our grid system, we have the 20th largest electricity in the system in the world. We have the biggest battery that exists on Earth and will ever exist on Earth in the Grand Coulee Dam, most likely. I mean, it's not what we think of as a battery, but it's a big storage of energy behind there. We've got literally the world's largest producer of smart meters over in Itron in Liberty Lakes area. We've got the largest producer in the world of smart relays or Synco phasers and Schweitzer Engineering Labs over in Pullman. It's now GE, just got bought from Alstom. It's been bought many times, but literally GE's Grid Analytics that run grids all over the world is based in Redmond, Washington. So our large companies that work all over the world on grid technologies are amazing. And then from that, we also have utilities like Avista, PSE, Snowpud that have been very aggressive and very kind of forward on what you'd call smart grid. Now it's being called grid modernization. But that idea of making our grid as efficient and smart as possible. I mean, there is a big argument before you put solar on it, just like a house. Before you throw a bunch of solar panels on your house, be really smart to make sure that house is as energy efficient as it can possibly be, because otherwise you're just wasting energy by creating this solar energy in an inefficient house. It's not unlike our grid. I mean, if we're going to transmit massive amounts of energy, which we do, we should do that in the smartest, most efficient way. And by making our grid smarter, you can delay or offset the need for generation. I won't get into it, but so if you're really concerned about carbon, a good way to keep carbon low is by not having to build new generation, and a smarter grid will help you do that. And also, there's a lot of energy storage companies that have, and very interesting ones, because of resources we have like PNNL, which have amazing biofuel research, grid research, but we've got storage companies like Uni Energy Technologies up in Mukilteo, creating batteries that are very different than they're not lithium ion, they're grid scale, and they're different than anything else anybody's making. So exciting companies like that with lots of potential. And then the third one is, the third area that this state has always excelled in is biofuels, and I'd go to bioproducts now, and we'll probably get into why that is. But that ability to take, we have lots of natural resources. We've always been a natural resource extractive community. So if it's wood waste, if it's the research that goes on into algae or biological systems to create energy and stuff. Between PNNL, WSU, UW, we've got a very strong research background in that. And then with Imperium Renewables, which was sold last year to Renewable Energy Group, so it's not actually a Washington-based company anymore, but still that's the largest independent, or the largest single biodiesel refinery in the country. So we've got a big biodiesel footprint. And what you'll see, and what I'll talk about a little bit, one area that we're, because of Boeing and Port Seattle and Alaska and whatnot, we're very much on the cutting edge of biojet fuels. So we can talk a little bit about some of those developments, but I think we're very well positioned, especially in the US. Hopefully you'll see SeaTac be the first, their goal is to be the first airport in the US to fuel all of their planes with some percentage of a biojet fuel. And it's a realistic goal that could happen in the next couple of years. They're in the middle of the study now. So I could talk about a bunch of things all day, but I'd rather move on to the questions and answers and get to a point where I have a discussion with y'all. So I mean, anytime I'm speaking, feel free to interrupt me and ask, because I'd rather talk about what you all are interested in, and other than just blabbing on and on. So I'll leave it at that.
Okay, great, Brian and Evan. Well, I'll just start off with this question. In the biofuels sector, what are some of the basic issues, and I think we've already talked about maybe vertical integration as something to be avoided, but what are some of the basic issues behind a working relationship, or developing better working relationships between the public and private sectors, both at the state level when we're talking about public sector, and even the federal level? Mm-hmm. And are there developments in that direction?
Yeah, I mean, on the state level, you've got, I kind of break biofuels into two things. When we started biodiesel in this state, and it was kind of the front of that wave around 2004, 2005. The Midwest was a little bit ahead of us, but not much. Europe was far ahead of us in that sense. There was this hope that we were going up against big oil. We now know we weren't going to beat big oil, but I mean, the hope was to get there, and getting there means you become a commodity effectively, which isn't necessarily, it can be a good thing, it can be tough too, but I'd say we kind of got there. Biodiesel and ethanol in its traditional form, made from ethanol from corn alcohol in this country, biodiesel primarily from soy or canola, virgin vegetable oils, it's there. We have large infrastructure throughout the US to produce it. Sorry about that. We have large infrastructure throughout the US to produce it. You can get it if your state wanted to go to 90% biodiesel. There's probably enough for most states out there to do that. So it's not a question of can you get it or whatnot. Now it's the question. It's now become a competitor to big oil. It's a price thing. It's a performance issue and whatnot. So I think that's good, because it's now an accepted alternative to fuels. It's never going to replace traditionally biodiesel produced by crop growing through crops, even reusing waste vegetable oil. It is always going to be a small percentage of the overall demand of petroleum in this country, in the world. It's not going to be a replacement. It's going to be an alternative fuel, a true alternative fuel. Once you get into the next generation of what you could do with synthetic biologies or growing of algae and stuff, you could theoretically start to maybe get into a conversation of true displacement on a larger scale. So I guess that's to say, and that public-private partnership on the public side, I really feel like now it's a matter of what the community wants. Like if you want a high percentage of biofuels, probably in biodiesel up to 20% and is very, very accepted, and all the way up to 50%. Ethanol all the way up to 85% if you have the right vehicles. Like if you wanted to do that, it's a policy thing. You could do it, you can enact it. It's not a supply issue or anything, it's a policy. So in that sense, I really do feel like it is open. You'll see the different policies. We have, unfortunately, a pretty weak policy. I mean, we have some state mandates. We don't have any mandate in this state to have a certain percentage of our fuels be biofuels. Oregon does. A lot of other states have statewide mandates. Or you have other policy pieces like a low carbon fuel standard, which I would say is kind of the gold standard of if you really want to get a true mix and a true growing mix of different types of biofuels into your fuel system, low carbon fuel standard has been the way that's been most effective. California being the state that's just going crazy with it. Most of the biodiesel that gets produced in our state all goes down to California. I don't like that, but I'm glad they have the market, but I'd prefer to burn it in our own state personally. We have Governor Inslee wanted to get an LCFS, not this last session, but the session before. A poison pill was put on our transportation package, where if an LCFS is implemented now in this state, our transportation package would be, I forget the exact mechanism, but basically be null and void. So a poison pill, we will not have a low carbon fuel standard in the state until 2022 with the current poison pill. I would call that a real shame, but it is what it is. So, is it still not working?
You can just use an acronym, Brian. LC.
Oh, sorry. Low carbon fuel standard. I won't get into the full mechanisms of it, but it's a way to mandate uses of fuels based on a carbon intensity number. So trying to level the playing field by not saying we're going to use biofuels, we're going to use this, but looking at each type of fuel's carbon intensity number, and it gets very complicated, but trying to get to a lower carbon intensity of your overall fuel supply by using a variety of different biofuels. Sorry, I just fixed this right now.
One thing I would add in terms of not the state level, but the federal level, one thing I've noticed, going through grad school and looking at research funding is that, research funding for basic research, even applied research towards biofuels or renewable energy, that really allows folks in kind of the academic world to be at the cutting edge of figuring out how to make these things truly, 10x, 100x better. That funding, goes away very quickly if you change, governance at the federal level, or something happens and suddenly everything's gone. And now at that institution, if you have a couple people graduate, suddenly you've lost a lot of knowledge, because there's no funding left to keep those students on those projects. And that professor then has to go look at other projects. And so now, it takes a while to build knowledge, and it's so quickly lost that we lose a lot of steam every time the research cycle or research funding cycle, kind of takes a dip because of either, economic change or political change. So I think that's something where, if we're interested in developing these technologies, we'd have to start, just like there's been this recent, moonshot by Joe Biden to go after cancer. The same sort of thing would have to happen with renewable energy, where you make a commitment over the long term. I don't know what the Biden commitment, they're talking about that, maybe 10 years, 20 years, something where researchers know that they should start investigating these issues because they're going to have funding. Their product is research, so if they don't think there's a market, they're not going to go into that.
I would say if you said one thing, like policy-wise, what helps biofuels, climate policy, anything, and what do we really not do well in this country, and probably state by state we don't do it well, is long-term stable policy. everything has been in this country, especially around any type of alternatives, wind, biofuels, 2-year cycles where funding, and then it falls off a cliff and no funding, and everybody just barely survives till 2 years later, the funding or the incentives come back, so then they go on. And it's no way to do policy. How that changes, I mean, in our current system, I don't know. I mean, it will take a true effort to get, I think, a lot more of our general populace on board with telling the politicians to make that stable policy, but it's not looking real great in the short term.
The government has cut back on basic research at the national labs quite a bit.
Yep.
Is that likely to change anytime soon?
Well, the whole mission innovation, so what came out of Paris this last time, and I wasn't in Paris. Oh yeah, so basic research funding at the national lab level by the feds and at a lot of different levels is cut back significantly. Is that going to change anytime soon? I don't know, but what came out of Paris, what you hear a lot about is the mission innovation and the clean energy, what's it called, the Breakthrough Energy Coalition. So the mission innovation is 20 of the largest economy countries in the world that are supposedly going to double down and agree to greatly increase basic and all levels of R&D into issues to help reduce climate change. So theoretically, if mission innovation becomes a thing, we're one of those countries, but it will also take us passing a budget that funds that idea, and that is obviously not a guarantee. The administration is going to push very hard to fund that. Right now, Murkowski and Cantwell have had some early success in pushing through and getting new energy bill through the Senate, not through the House yet, but that's a pretty major step, and it would be great if they could do it. So as in mission innovation, as it develops, if these 20 countries actually stay on course and do it, yes, you should see a very large increase in R&D. And then the Breakthrough Energy Coalition, which is our very wealthy folks like the Bezoses and the Gates and whatnot, that Breakthrough Energy Coalition is talking about backing that effort with a lot of private investment. So kind of one of the main things that came out of Paris was just that. If we're going to solve this, it's got to be a huge R&D effort.
So,
And I might have screwed up your system by telling people to ask questions. I'm sorry.
no, that's fine. I had a magical question, but I'll hold off on that. So why don't we open, it looks like there's a lot of hands out there, so why don't we, there you go. So we've got 2 microphones in here, and 1 on each side, so.
Okay, Brian, I've got a couple for you. What happened to Infinia Corporation over in the Tri-Cities? And the other one is some states or some utilities in some states are letting it be known that they're really not interested in having anyone make power but them. Mm-hmm. And the home solar industry is taking a kick in the shorts in Nevada and Arizona.
Yep.
So how's that being received around here? And thank you.
Yeah, so just so you know, Infinia Corporation was over in the Tri-Cities. They were doing what's called concentrated solar. And they were basing on what's called a Stirling engine, which is a very efficient engine that I won't get into because I probably can explain it real well. Stirling engines always hold a lot of promise. Nobody's really figured out how to make it work like everybody dreams it's going to work. Infinia had a system that was basically, they looked like big radar dishes that concentrated the sun into a little Stirling engine and produced electricity. At some point back in probably 2010-ish, they pulled the stakes and they moved to Utah, and then they don't really exist anymore. It was very expensive, so their kind of solar concentrating would have required thousands of these dishes, high maintenance, da-da-da-da-da. So it just didn't work out for them. But one of them, some of that research has always stayed in the Tri-Cities, so there's Infinia still does exist in our state. Now it's called Infinia Research, and they're using that Stirling engine mainly for military and off-grid applications for like efficient cooling on off-grid applications and whatnot. So The big Infinia that you're probably thinking of, they left the state and then went under, but there is still a lot of that base research, and those researchers still work away at the Tri-Cities. The second one was,
The utilities.
oh yeah, so that is very much that grid modernization that I talked about. That's part of that story. So you'll hear a lot of, and a Vista Corporation and a Vista Utility out in the east side of our state, Spokane, very small, like 300 and some odd thousand customers, which in the utility world is laughable, but by far one of the most progressive utilities out there. Itron spun out of them. They've spun out 3 companies that are much larger than that utility parent company. And you do not see spin-outs from utilities. Utilities are not companies known for their progressiveness. So we have a great jewel over in Avista, and there's a guy there, Kurt Kirkeby, who can talk about it. So that's the idea of what is the utility of the future. And there's lots of utilities that are very concerned that their business model is going away, that this idea of central generation that they control, that goes out to everybody else, and everybody says thank you very much and pays their bill, that's on their way out because of grid modernization, smart grid, where you're going to get to the point where you could choose to be a homeowner, have lots of solar, and sell directly to your neighbors. And why have a utility involved? Mainly the utilities own the distribution, which is where, but that model of going to, I think the more progressive ones will talk about that they see themselves going towards a utility as a service for hire company. So instead of just producing, they could sell you energy, they could just sell you services saying, hey, we'll make sure the energy that you produce is produced safely on your own house. We can help you. We've got the lines. We'll charge you to send the energy you produce over to your buddy who wants to buy it on the other side of town. So this idea of the utilities going to just a whole new model of how they make their money and whatnot. A lot of utilities have zero desire to be involved in that kind of conversation.
There'll be a lot of adapting.
Yeah, so it's a huge, I mean, that will be a huge sea change, and I don't know if it will happen to the extent I'm talking about, but there's definitely a lot of very nervous utilities and a lot of people thinking about along those lines. And again, PNNL is leading it. We can talk about it, but PNNL and NREL, the announcement official will be made in the next couple of weeks, but the next round of, the largest grid modernization smart grid project ever pulled off was led by PNNL in this region. It was a 5-year program, $178 million, just ended in 2015. By far the biggest smart grid project ever done by PNNL right here. The first idea of smart grid happened out on the peninsula with a thing called, was it GridWise? But this idea of how do you look at a place like the peninsula, which is like the very end of a big transmission line, instead of, again, thinking about generation and stuff, how can you just use the power that's already getting out there more intelligently so you don't have to worry about building new lines out there or new generation and whatnot. So we've got amazing smart grid pedigree in this state, and I hope we keep building on it.
We had some questions up here, I think, if we could.
Chair, there's a student that's had a hand up for a while.
Okay.
So I have 2 questions. One is, did ever the Seven Sisters or OPEC think about biofuel? And the second question is there any side effects of it?
So is OPEC ever talked about biofuel?
OPEC or Seven Sisters?
I don't know. I doubt it. I don't think the OPEC nations see biofuels or ever have as a real existential threat to their livelihood. So if they have, I don't know. I will say Boeing has an amazing, cool project over in the UAE. What you're seeing more is OPEC countries understanding they have to diversify away from that and spending lots of money on renewable energy. Boeing's working with the UAE to grow what are called halophytes, saltwater-loving plants that can produce oils. And so you're getting into that idea of reducing desertification, reclaiming the desert, and greening it using salt water and combining the growth of halophytes that could produce biofuels with like fish husbandry or aquaculture and big mangrove fields that are very good at remediation. So true kind of integrated system. So I wouldn't say OPEC is worried about it. What I'd say is they're investing their money in renewable energies because they also see that as the future. And then the last one, I didn't get it.
He wants to know about the scientific facts of it.
The side effects of
Side effects.
No, side effects of biofuel production, of
Side effects. Side effects.
side effects, yeah. Of what, though? The production of biofuels? Yeah, I mean, there's lots. That's a big question. You probably, you answer that one, because
But
I mean, we could both probably talk forever. I mean,
I think if you're looking at the ecological consequences, it's not as cut and dry as biofuels make the world better, oil makes it worse. And I think one of the challenges that you see on the technology side is, if you want to create a viable technology, you're often, going away from, like we were talking about, going away from using new feedstocks, using stuff that is simply produced for the biofuel, because that does have these side effects of taking away, arable land for growing food, or hurting river systems or things like that are already stressed. So now looking at waste to energy is, I think, a more reasonable approach from the tech side.
the sustainability issue around biofuels is long, has a long history, very contentious. And it somewhat depends on your point of view. They are not perfect. Biofuels, at least the ones we have, are not perfect. I would say none of our energy sources are. There's a very large oil, food versus fuel argument that's very real. And it hasn't been solved. The true life cycle benefits of biofuels, all sorts, lots of work going on for it, but still it's not I wouldn't say it's a science that's been decided and said, these are the good biofuels, these are bad biofuels. They all have give and take, and then it's a difficult conversation, believe me. There's lots of different organizations, like the Roundtable on Sustainable Biofuels is probably your biggest international organization, working very hard to get a sustainability standard on biofuels. You then get into, I mean, if you want GMO anything, the transparency of supply chains is what all this requires, and supply chains are extremely difficult to make transparent. Oh, sorry.
Go ahead.
Yeah, excuse me.
Thank you. More of a technical question. You may or may not have an answer for me. Biofuels, whatever their source, they're displacing oil and coal that is burned to produce energy. Are they going to reduce, increase, or maintain the same levels of emissions into the atmosphere that are a primary cause of global warming? i.e., we switch to biofuels today, everybody 50 years from now, is it going to be any different than if we had just stayed with coal, gas, and oil?
I mean, that's, you're essentially asking, would there be more CO2 in the atmosphere?
Yeah.
And, I mean, simply put it, the plants are pulling CO2 out. So if you're using them, you're more or less staying neutral.
Well, fuel implies a combustion. You burn something to produce. Are they going to be giving off the same amounts of CO2 is my question. If you're using algae instead of oil and coal, and algae is pulling some CO2 out of the atmosphere,
Well, it's
is it going to be
any,
a break even, or is it
I mean,
still
any
gonna be-
carbon that's going into the algae or the plant. Say again?
Oh, the mic.
Any CO2 that's going into the plant or the algae will be re-released, or some of it might end up just kind of going into the detritus, going into the soil. But you're not going to then, the challenge with fossil fuels is that it's taking carbon from a long time ago and re-releasing it. So it's more of a rate thing. It's not necessarily just, it's all carbon that came from somewhere and went into plants. But when you do oil and gas and other stuff that's been in the earth for a while, you're releasing more. That rate's increasing. Whereas with the plants and algae, it's essentially staying flat.
So, I mean, if you combust anything, it is going to release CO2.
Exactly.
Yeah.
So that doesn't matter. So that's why all biofuels, most everything you think of these days in the sustainability world, you'll always hear life cycle analysis. So it's that life cycle of, if you look at from the minute you till a field, plant a seed, put fertilizer on it, do everything, drive all the trucks to there, and you start adding up those carbon numbers all along the way. They harvest it, they bring it, you turn it into a biofuel, it's got carbon on it, and you track all that, and you say, okay, you've got that life cycle of a biofuel versus the life cycle of of carbon, and that gets back to exactly what he just said. That carbon, all our dead dinosaurs that have been under pressure for so long, we're pulling it out and we're re-releasing stored carbon. And just like our oceans have the most carbon by far in it. And if you start releasing that carbon, you're going to get into a lot of problems. So whereas plants, it's a life cycle. So they are pulling carbon dioxide out of the air. You're then processing them. There's a carbon impact to all of that all along the line. You're burning it off, there's a carbon impact. And then what you want for that life cycle is that that fuel is either neutral or less carbon into the atmosphere than other alternatives.
So, is it?
Yeah, and if you really want, I mean, if you want to, the EPA, if you want to get to it on the policy side, what we've decided is when the feds look at our renewable fuel portfolios and whatnot, the EPA has carbon intensity numbers for all different feedstocks, all different fuels. So that's, you can easily look that up. And if you believe that, even those life cycle analysis aren't perfect, CARB in California also has their list. So yeah, there is, it's never agreed upon totally, but yeah, there are numbers out there where you can get a good feel for what, and that's where you get into biofuels, RINs, renewable identification numbers in our federal system, and their value is based on kind of the advanced nature or the carbon intensity of those fuels. So like the kind of fuels he's working on are going to have much better carbon intensity numbers than traditional ethanol.
Well,
But ethanol is going to be better than traditional petroleum.
And that's a moving target too. I mean, as there's innovations, presumably you guys are working at more localized production, right? So in other words, being able to produce biofuels locally, and that's another problem with traditional fossil fuels is the supply chain geographically is usually much larger, and that entails carbon use.
Yeah, I mean, that grid question, distributed electricity, and if we got to distributed fuels, that would definitely disrupt some systems too. But then the hard thing there too is like an electron is an electron. Whenever it's made, it's going to run your phone or whatever. Fuels, if you like hydrogen, well, you need a different engine, you need a different infrastructure. So fuels on the infrastructure side get real expensive and real tricky. That's why everybody wants a drop-in fuel. You'll see almost everybody that's working, unless they're doing hydrogen or one of those things that requires a change, the buzzword is always drop-in fuels. You want to be able to drop your renewable fuel into the existing infrastructure of pipelines, engines, storage tanks, and things like that.
Yeah.
So we had a question back here. Bengali?
So what's the distinguishing feature between the first generation biofuels and the second generation biofuels, and which one is more cost effective?
Well, I think looking at what we're doing, I think that the difference between the older generations and the newer ones is in some ways, that idea of do you use, what would you call them? Just whole feedstocks, things like sugarcane or corn. Are you looking at waste to energy? Are you looking at also how much are you focusing on the molecular engineering? How much are you willing to, are you doing GMO stuff or are you not? I think there's also interest in, if you are going down, the genetic modification route, changing what an organism produces. So an organism that might not naturally, off-gas methane or ethanol, but grows really well. You might say, could we take, the ability that this other organism has to, create a gas that it's useful, that's more like a drop-in technology. Can we put that into this one that grows really well and create, a synthetic that, would be more economically viable? And as we get kind of more technologies at that molecular level, that toolkit expands and it's becoming more reasonable to make those modifications. And a lot of that, I think, is actually coming out of basic research and also, interestingly, cancer research. The business that I am a part of originally spun out of work at the Fred Hutch. And so, there's biofuels, we might talk about it as this distinct thing, but biotechnology is a field that really crosses across applications faster than we might think.
I'd say on that economical, current biofuels, first generation biofuels, are as close to economical as you're probably going to get. I mean, the infrastructure is pretty built out. We've got refineries, we've got the ability to move it around and whatnot. It's still subsidized almost everywhere, and then it depends. Is it economical? What's gas going for? And then what's their underlying feedstock, vegetable oil, going for? Right now, it's actually surprisingly closer to cost effective than we used to not be able to make it for the price they can make it now. So even with oil very low right now, it's not completely out of the ballpark. The next generation, I would say there's zero cost competitive right now. I think that next generation is really working on getting the right technology to then scale up. I think that cost competitiveness will come once you get technology that they can start scaling in a large way. And most, especially the guys, I'm going to forget all the names of the ones down in California, but those early algae companies that you saw really make a big splash back starting at 2004, going into kind of up to 2012, talking about algae in a big way. They're going to change the world, they're going to grow algae, going to displace petroleum, da-da-da. Any of those companies that still exist are focusing on high-value co-products that they can produce. And it's the same thing that oil companies do. You don't make your money off diesel. It's a commodity. It's the lowest margin. They fight over quarters of pennies. It's all the leftover stuff. I mean, the petroleum guys are making all those high-value petrochemicals. That's where if somebody's going to pay you $30 for an ounce of something, it's a lot more lucrative than even $4 for a gallon of something. I mean, so that's where I think you're seeing, I think a lot of the early algae companies realized we don't need to tell this story about how we're going to displace petroleum. Petroleum's a low-value commodity relatively.
So high-value examples would be like high-quality plastics or lubricants?
Yeah, or the precursor chemicals to make those. So there's lots of, I mean, anything. There's a company around here back in the day called Blue Marble. They're over in Montana these days, but they started looking at biological processes to make fuel, and now they're using biological processes to make fragrances and food flavorings. And the Mars Corporation will pay you a whole lot more money for just a little bit of food flavoring than somebody will pay you for a whole lot of diesel. So that's... Sorry?
What does it do for our environment?
It's probably, I mean, it's the same thing. Those chemicals they're producing are often replacing petrochemicals. So in that sense, it's almost the same industry. It's those refineries, all our refineries up north and a few down south. I mean, they're producing a whole range of different products. So a lot of those same products they're trying to replicate those through more sustainable practices effectively.
And I would add to that, in the short term, you might say, okay, if an algae company is producing a fragrance or something, that you're like, how does that directly help us right now? And maybe, I don't know the life cycle of a fragrance, but I think, as we start to think about these photosynthetic organisms like algae and plants as, the producers of a variety of chemistries that are needed, you start to create a set of companies that has that expertise. And so, in the short term, they might not find that magic bullet, but it creates a whole industry that then is stable and can start to build on itself and build layers. Because that's one of the challenges we have now is that, because you don't have a lot of algae companies that, have worked and scaled and have, there's no GE equivalent, there's no Microsoft equivalent that then becomes the base of the industry in a whole region and allows, startups to just, ping pong around. And I think that's, my hope is that this wave is right now and that, we're at the right place and the right time so that, we can get one or two companies to scale and be stable so that those next set of ideas have something to build off of.
Can I kind of follow up with this question? It's related to that. How much is the Puget Sound or the Pacific Northwest have a comparative advantage in biofuels or some of these spin-off potential compared to the rest of the country or even globally? And I ask either of you that.
Yeah, I'll start on where Imperium came from. I guess the old regime, if you're looking at why there's biodiesel out here. And why? Well, A, we all lived here, and so that's why we wanted to stay here. But also, we looked at it, the early biodiesel was all Midwest. It's all soybean in this country. And that's, well, you could get into arguments about feedstocks. But it's all smaller plants, Midwest, railed around and whatnot, and that makes sense. You're close to the crops. We looked at it from a different angle and said, we will take it and we're going to make it on a deep water port in the Pacific Northwest and open up the potential to move that anywhere. And that's where you see our refineries. You don't see as many refineries landlocked in the middle of the country. They tend to be out on the ports. So we had that competitive advantage early on that we made. And then you'll see the biggest biodiesel plants. There's a whole lot of smaller scale ones in the Midwest. The big ones are down in Texas and out here in because of those economies of scale you get through ocean transport and whatnot. And then we also, if you like canola oil, rapeseed in Europe makes a pretty good, maybe a little bit better than biodiesel, soy-based biodiesel, makes a good product. And Canada, canola oil is invented in Canada, and it all comes out of there. So we're pretty close to that. And you're seeing more canola grown in Washington. We can rotate it with wheat and other things. So we've got some comparative advantage there. Like ethanol, none. You don't see much. You got Boardman down in Oregon, but you don't see much ethanol out here because it really makes it's so established out in the Midwest that we didn't have any advantage, so nobody built anything out here.
What about
next generation is
R&D
different.
context?
I would say on the technical expertise side, one thing that I find really unique about the region is that we have a pretty broad base of technical expertise across hardware, software, and biotech. And I think that's unique. Looking at the other regions that are big, so Boston, San Francisco, down, the Research Triangle in the Carolinas, maybe down in San Diego for biotech. They might have two of those three, but not all three, like we do. Luckily with Microsoft and Boeing as these, kind of anchors, we have those two, and then, the Hutch and UW on the bio side. And I think that is kind of the next generation, is combining those three. It's like my workbench at work literally is, 1 part computer, 1 part microbiology, and 1 part, machine shop. And there's not many places that are like that. And I think, that's what's starting to become more common in this area and could, create the possibility for some really unique inventions, which is exciting.
Sadiq, you've been waiting a long time.
Thank you. I have a 2-part question. First for Brian. If we were to succeed in having a breakthrough through biofuel and reducing our dependence on fuel, how would that work the relationship with countries such as the Middle East, who we are highly dependent on getting oil from? I'm wondering if there's politics involved, or is it basically corporations having the upper hand and not having energy efficient companies or vehicles, because they're unable to, I want to say exploit or get a cheaper labor going more of an efficient way. And also a second question, if we're all able to, by 2025, have that breakthrough, can we sustain ourselves within the United States, or are we going to have international ventures looking for natural resources to basically sustain the future for biofuel?
Yeah, and the first part, if we truly had that breakthrough that happened over a relatively short period of time, call it 10 years, it would cause world disruption. There's no doubt about that. It would be shocking if that kind of change happened that quickly. So I guess I would be surprised to see something like a biofuel create such an immediate shock, like come on so strong it caused such immediate shock that you would have global disorder or something. I think it'll be a slower progression. I think you're already seeing it in oil countries in the Middle East. They might not all be clean tech, but they're realizing we better spend all this money on finding new areas to become great at. And I think that's a good thing for that area. I mean, it's good. It's good for an economy to be more diversified anyways. So could it potentially cause really serious disruption? Yeah, I just don't think these kind of things play out on that fast of a time scale. And I bet you some a lot smarter political scientists and stuff could already talk about how just this move towards oil being the assumed what we're going to use towards looking at alternatives has probably already started some of that transition. But I think it also is probably somewhat, we don't even notice it because it happens over time.
In terms of the second question about, if I understand it correctly, you can tell me if I'm wrong. If we have a breakthrough that allows us to use the sun's energy much more efficiently, would the U.S. be able to kind of, not be an isolationist, but not depend on foreign energy sources? Is that right?
For natural resources.
Foreign natural resources.
Feedstocks.
I think, the U.S. in terms of where our population centers are and, how much sun we get near, areas that can transport things, it would be challenging. But that's a little bit out of my league, but I think it would be challenging for us to, this might be a geography question right here, looking at where people are on the coast, but a lot of the good sun down south, kind of maybe more central. Is it feasible to, can you move that energy outwards, or do you move the population inwards? I don't know. So there's what's feasible and what people would actually do. I don't know. We move a lot, right, depending on economics. It's like there was a study out in the Times about how folks under 30 all live in the suburbs now because it's cheaper. And it's like, oh, well, maybe if it was cheaper because people, down in Arizona had cheap energy, cheaper than here, maybe there would be, moving to the Sun Belt even more. Yeah.
But this newer generation, if I'm not mistaken, some of the newer generation biofuels that you described up there, the hope is for waste, right, as the feedstock?
Well, I think that's what's feasible economically, but not necessarily at huge scale. When I talk about like the third generation or things like biological photovoltaics, where it's basically, an organism that gets hit by the sun and can transmit an electron directly to a piece of metal, I think that's exciting and interesting, but the ability for that to power a whole nation, I think, that's not going to happen by 2025. Or if it did, I'd like to be part of that company because that'd be great. But, yeah.
And a lot of it too, just like anything else, like I said about the grid and stuff, efficiency within. We shouldn't. It's going to be two parts. It's going to be what we produce and stuff, but it's also how much we need. We need great leaps in efficiencies of engines and whatnot. There's kind of two parts to that. You got to reduce your demand. Is when you're trying to find a second supply, that's great. But if you're not at the same time reducing demand, you're not. In my opinion, you're not getting to the heart of the problem. You've got kind of two things. And I mentioned, you're not going to happen quickly. The U.S. is not dependent. We're a net energy exporter now. We're not dependent on foreign countries because of fracking. We are now a net, and so I was kind of wrong. It can happen very quickly. That was more of a price. It was a new technology that allowed us to greatly reduce the price of something. But like that has, in the last 10 years, blown everything else out of the water. Like that's what OPEC's worried about. OPEC, biofuels is not their big thing. They don't. But
There was a question over here.
Yes, I was just curious, what incentives on either side of the coin, economically or technologically, would help to push biofuels into the mainstream for everyday use?
No, you've got an on like biodiesel stuff. You've got some tax credits. So tax credits, anything that reduces the price helps. I would argue the best mechanism out there right now is that low carbon fuel standard scheme that is fairly proven. It reduces the carbon intensity of your overall fuel pool, and it's not necessarily incentive based. It's not giving somebody a direct subsidy. Mm-hmm. It's making a market. It's saying we have this much overall demand. We need to fill that demand with a bunch of different things to get to a lower carbon number. So I think that's the most effective because it's basically it's providing a market for the newest biofuels out on the market. Like if you can get even a small amount of, in a low carbon fuel standard, if you can get even a fairly small amount of really advanced biofuels, the kind of stuff Matrix is working on, that's got a really high value because it disproportionately can pull down that carbon intensity number. So companies will pay you a whole lot of money for that. So, as far as policies that exist right now, I like the low carbon fuel standards.
I would just echo that. Anything that makes the market generally for technologies like the ones that we develop, that it doesn't need to necessarily be a subsidy, but increases that demand is huge, because I think right now, companies like ours, similar to the one you mentioned before, you start out as a biofuel company, oil goes down $80 a barrel, and suddenly you have to think, okay, how do we survive? And we have to start doing R&D for different types of products, because that market has changed. So if you can create demand and keep it sustained, it allows groups like mine, to raise more money, because investors say, yes, this is worthwhile to give you, 5 years to work on this, because we know that, in that time frame, the market's going to be there.
So I think we have a question up here, if we can get the mic.
Okay, Evan, on the algae side, now, back when Brian was talking about earlier, the ancient days of algae technology and Exxon commercials, the big deal then was water. It used huge amounts of fresh water. Now, is that still the case, or is it changing, or is the water still good for other purposes once it's been used? Thank you.
Yeah, I think folks are looking at a number of ways to get around that. So there's some interesting research on how to use wastewater, so that you're actually pulling excess nutrients, so things that might have been fertilizer put on a field, goes into the wastewater. You're pulling that out. Now that's usually done anyway through chemistry at the waste site, and so, or the waste management site. So if you can use waste, you're going to get paid to use it. Now, in terms of using kind of a new source like freshwater, there are algae that are marine, so they're saltwater, and I think that's something that's been interesting for folks, is to try and figure out can we use those. Right now, I think where I'm at and where a lot of people are is just at the basic level of, can we get this organism to grow faster? Can we get it to produce something of higher value? We're very early on in the R&D world, so we don't necessarily even worry about, will this be cost effective? We just try and say, can we go from 0 to 1 and make it work? So unfortunately, I might not know the most about what's going on in the bigger picture, but I do think there's a lot of engineering going on at the forefront to allow for things like marine organisms instead of freshwater, so you don't have that competition.
I think in general, too, early on days, there was these ideas you're going to have these big racetracks of outdoor growing of huge amounts of algae and stuff, and it was going to be extremely water intensive. Then you got to get all that water out, which is extremely energy intensive. That general idea, at least in the short term, that we're going to see hundreds of acres of algae growing in outdoor ponds and stuff that are very water intensive, I don't think many companies are running down that road anymore. So more, I think it's bioreactors, and they may still have a pretty high water demand, but nowhere near what those early, like the Exxon commercials and stuff, used to portray.
When were the Exxon commercials?
Was it Exxon? I don't know if it was Exxon. BP was Beyond Petroleum for a good 5 years, and now they're back to British Petroleum. But there was a time when they were Beyond Petroleum, and they owned a bunch of wind, and they divested.
White lab coat with the food coloring and the food Carlin Myers.
That's what we do.
Some guy going like this and telling you the world's going to be better now.
Yeah. The one thing we haven't talked about in this state, as far as advanced biofuels and ethanol, which I've kind of forgot, is the idea of getting wood waste. And that's where you'll see our researchers that are very good at WSU, UW, PNNL, lignocellulosic, the ability to break down wood products and pull valuable fuels and stuff out of it. We do. So on the ethanol side, that's where we have a lot of research. He knows that. That's why they use grown poplars real fast to try to do that. So, yeah.
This might be for Brian. How much resources and willingness is there at the government level to actually change our daily energy use consumption? The reason being, regardless of what the next source of energy is, if we continue to use it at the rate that we are using it, which is to some extent abusive way of using it, it doesn't matter what the next source of energy is.
Yeah, that gets into the efficiency of things. Our state has always been very progressive with efficiency standards. Our city, Seattle's got some of the strictest energy building codes in the world. We've always, and we still put a lot of money into, at the state level, energy efficiency of houses, especially lower income houses and whatnot. So it's actually the easiest thing and the least political, the lowest, or the, it's not a hot potato politically as much. Most people agree with energy efficiency. So it's probably where we don't put enough as a nation, probably not even enough as a state. We put a lot into it as a state, but it is one area that we actually do spend a good amount of money because it is pretty, it's not real controversial. Everybody agrees we need to use less energy. I'm not an energy efficiency expert. There's, like I said, NEEC, if you're in Northwest Energy Efficiency Council, Stan Price. I mean, if you want to get into that world and understand it, we've got some really cool resources. We've got a smart building center down at the old Amazon headquarters, a PAC Tower, that will tell, and this gets into, so where we are spending R&D money in the state and in the region is, again, getting into smart grid and stuff, but smart buildings and stuff. So taking that next step, I mean, we get it. We know how to insulate things and we know what energy savings that is, but we've got a lot of companies doing really cool stuff on that next step of making those buildings operate in a much different, much more efficient way. So I'd say I don't know the numbers. That's a good question, like how much in the state we fully attribute to energy efficiency, but it's a big number.
I have a similar question on the funding for R&D, kind of the long-term stable policies and the problem getting that that money. Is that a matter of education and public opinion, or influence of the private sector over the public? Could you talk about that?
From the state side, I'd say our governor, what I do, we agree, yes. And that we have a clean energy fund. I haven't gotten into the clean energy fund. I could talk about it. Right now it's $76 million. We've got towards a clean energy fund. 23 of that or 25 of that is been directed specifically towards matching grants for R&D. So in clean tech and clean energy, there's an RFP process in the works, right, or we're deciding right now. There's 2 other ones coming up. We ran a whole series of ones from 13 to 15 that provided matching funds for R&D projects. So I'd say from the state perspective, we 100% agree. I mean, if we're an innovative state, if we've seen what innovation can do for the state, it starts with funding R&D. So this current administration is very for it. That does not mean that all the politicians, both on the R&D side, agree. It's constantly a fight.
Do you have an opinion on the national level of that?
You might. I mean, it's always a fight. Why we're cutting back on national lab funding, I have no idea. I mean, to me, I don't understand it, but there's just a lot of people that either just don't think that taxpayer money should be given to people to do science projects, as they call it.
Why is that?
I'm on camera, right? I would. I think there's some lack of education in a lot of public and a lot of lawmakers. And
is that influence of the private sector, do you think, or more education?
No, the private sector. Here's a good example in this state. We just got rid of an R&D tax credit. We did have an R&D tax credit in this state. It just went away this last session, or 2 sessions ago. And it was specifically because the people who were taking advantage of it were big corporations, Microsoft. Well, they weren't the only ones, but if you're going to have an R&D tax credit, big corporations are going to do R&D and take that tax credit. So there was plenty of big corporations doing it, but there were lots of small companies doing it too and taking that tax credit. It was much more valuable to those small companies. But what I would call a very limited view, people are like, it's corporate welfare. We're giving tax breaks to Microsoft and Boeing, and I get it, and I don't love that either. But to then throw the baby out with the bathwater is ridiculous. I mean, we at least should have passed something where you can get this tax credit up to a certain level, your company's at a certain employee level or income level, whatever it might be. So yeah, politics gets involved.
Thank you.
You might have.
I
gets
mean,
funded by these things.
Yeah, I think looking at the private side, I think investors, make a calculation of, will this give me a profit at the end of the day? And it's pretty simple when, if you're pitching them on I'm going to create biofuel and oil's down at 40 a barrel, like it's a hard sell, to say the least. I think what you're seeing now that's, I hope, changing the game a bit is pitching people on, these sorts of technologies as enabling technologies. It's not like we're a biofuel company, we are an algae products company. Our expertise is in engineering algae to do different things. And so you're starting to, switch how you think about that. And that's happening over, I think, also on different parts of biotechnology. You look at like the big companies coming out of here for therapeutics. It's building an expertise in how do you engineer cells to do things. It's not just always kind of this, binary, is this solution going to work for this one market or not? Because that's when you get stuck, like we've had a number of companies that, almost make it and then, the last trial goes wrong and they're done. And that expertise is lost.
Is there a solution to compete with the market? Is that the only way to survive?
Well, in my world, you kind of you do. I think, we as biotech people, I hope, are kind of moving and getting smarter at understanding realistically, what are the technological barriers and going for the ones that are immediately in front of us first. I think I look at the computational side as the biggest barrier right now. Since we can't predict what a cell is going to do, we waste a lot of time and energy just trying so many different options. And so if we actually stopped and addressed that need and created a tool for that, you then allow for many more applications. And so I think, I'm sure someone's going to do it. It's just, where and who. But, if I were going to investors, that's what I would pitch. I'd say this is an enabling technology. Invest in that because it's going to be used by everybody, whether it's for cancer, whether it's for ag, whether it's for whatever. And I think that's how you get around this kind of stumbling block.
I also think there's, private companies are good at R&D, especially R&D that's going to make them money.
Yep.
And what the mission innovation, what the big thing is right now is where the government, where non-profit seeking entities should step in, and what we're falling down on is basic research. So that's the stuff that's never going to make anybody money, but it's always the foundation for things that eventually make people money. But we have this blockage where we don't want to fund a bunch of scientists and their science projects because what does it do? There's no value in it. Science doesn't work that way. There's a lot of value in it, and that's where we're falling down, I'd say, on the national level, probably the worldwide level.
Agreed.
City?
Quick question about solar panels. I used to volunteer with this NGO. We would travel throughout villages in Afghanistan and deliver solar panels. And I was surprised on how easy it was basically to provide the necessities for them to charge their phones and even watch TV. So I'm trying to figure out how that's not taken forward to countries that need the basics such as food, shelter, and now electricity, which I feel is another necessity that we need. And if there's any push for delivering more solar panels into villages where they can at least have that start to get the electricity going for them, instead of building power grids, which there's a lot of money involved, and I feel like solar panels can start the job.
It's a good question. I'm not sure.
There's, I mean,
right answer. Yeah.
Like State Department, I think, runs it. There's one like Repower Africa. There's some efforts there. There's lots of, I don't know the big ones, but there's lots of efforts to get that. And that gets into the idea of what you'd call microgrids. Another place our state is very good at. Alaska is full of microgrids, places that don't have centralized grids. And that's another thing, like Africa is probably, as it develops a more electrified infrastructure, it's probably not going to be, and parts of China stuff, it is not going to be a traditional centralized generation going outward. It is going to be a bunch of little microgrids. It's going to be, but even microgrids, like a solar panel is great if you're doing a phone stuff, but you still need some battery, even though they're still going to have some lead acid or something. And then even in a small, even if you want a little village or something, you've still got that grid aspect. So you can produce it with the panel, but you got to transmit it around. You've got to get quality power so you don't brown out and destroy all your electronics and whatnot. So it's a little more than just a solar panel, but I agree, yeah, that a microgrid, so where you'll see, India is probably going to be the best example of lots of little microgrids powered by solar, small wind, small biomass, and things like that. So Is it happening at the rate it needs to? I don't know. But now solar panels are so cheap that I think you're going to see, you already saw the adoption of it. It's starting, yeah, I think you'll see a lot more adoption. I mean, solar's in. Solar competes now in the US down in Arizona with, it is not a, we should do solar because it's green and pretty. They do solar because it's cheaper than coal. I mean, so in that sense, that's great. I mean, solar's gotten to the point where it can be competitive.
Is there any research going on now on methane hydrates, and is global warming going to cause any issues with the hydrates?
Could you explain that a little more in turn? I'm not sure.
That's methane-bearing ices at depth in the ocean that
On the seafloor, under pressure, they form into stable ice.
You know, it's not my vein of research, but I know methane generally is worse than CO2, and so I'm sure that, you know, folks are looking at that.
Yeah,
So.
I don't know of any direct. I guarantee you there's somebody researching it out there, but I haven't heard of any projects specifically aimed at. I think most of it is you got to quit and make sure the permafrost doesn't melt in the first place. That way, it never gets released. But I don't know. That's a good question. I don't know of specific research towards like trying to maybe capture that and use it or anything like that. But that's not to say it doesn't exist. I don't think it exists in our state.
Trapping probably around the bottom out of it anyway.
So I think we have one more question. Time for one more question.
Okay, so I have a question. So compared to electricity cars, and I still see a pretty high of to produce bio oil, and Tesla also have a power wall plant, and also the wind power and the solar power. So I just wonder what's the advantage of the bio oil?
So basically you're saying, renewables that provide electricity versus biofuel, which is liquid fuel, right? And there's many applications where you're not part of a grid, not even a microgrid. You're just out there. And so liquid fuel for those applications, I would imagine, I would bet for defense applications especially, defense is usually a huge user of fuels. And part of that I would assume is because they want independence, not having to rely on things, being able to move without needing grid access. So I think there's a large market for liquid fuel because of that independence from a grid or from a battery source. Also longevity. You don't have to worry about the liquid fuel degrading as much as a battery over time.
Yeah, very, very different applications. And I will say, I mean, in our state, we didn't get into it. We should use more biofuel than we do. But if you really want to, if you want to reduce carbon in our state, build out our electric car infrastructure, because we've got the cleanest grid in the country, and it's only getting cleaner. I don't think you'll see the coal plants are going away. The carbon intensity of our grid continues to go down. It's already the best almost in the world. So electric cars and we have the cheapest electricity. A true electric car infrastructure throughout either regions or our whole state, you really start knocking down carbon numbers from our state perspective. Our state perspective in the whole scheme of things is not huge, but we have control over our state, so we should be the best that we can. So that's another whole different argument. Like, do you spend time on biofuels, or do you spend all your time and effort on electrification of vehicles?
One last question for Evan. Approximately in the Pacific Northwest, in this region, how many companies like Matrix Genetics are there? And do they share information on research and development?
Yeah.
Is that a challenge?
Yeah, there's not many of us. I think Matrix is probably the only one around. I don't know of anyone doing algae right around us. I mean, there's some folks doing things at UW, but not at an industrial level.
In PNNL, they're SQUIM. PNNL's got an
That's
amazing
true,
campus
they're out
out in SQUIM, if people don't know that, mainly in Tri-Cities. Amazing campus.
So there are other centers of research and development, right?
Yeah, so they do a lot of research.
Information?
Well, I mean, that's,
I know
public
it's for
and
profit.
private. It's, I think I think I mentioned, we were talking before at one point, that there was only recently kind of this first example of scientists actually sharing data with each other. We're really actually not good at that. You'd be surprised, but when we write papers, especially in academia, your ability to move up depends on your ability to publish a paper. And your ability to publish a paper usually depends on you finding something really cool and crazy that no one's ever found before. And unfortunately, I think people tend to, in order to get that cool, crazy thing on there, you use data that might be a one-off that you really can't reproduce. You say you can, or you have just enough to get you in. But when it comes to folks like me who say, okay, this has been published once, now let's make it work. Like I was actually talking with someone today where I don't know how many papers we found where it says that we should be able to do something and we try and replicate it and we can't. And you can't go to that scientist usually, or it's just not something we do, and call them up and say, hey, you tried to do this, how did you actually try? No one ever has that conversation because that's their IP, and we don't share those things, especially industry to industry. And it's unfortunate, it is holding us back, but I do hope it's starting to change. There was a recent project where someone put out this data and made a statement and said, we think this data shows that this organism does X, Y, and Z. And another lab, because they could actually look at the data, said, no, that's not true. You have contamination. And they could gather up enough people and show that that actually happened. And that was great because the science actually moved forward and all of us can now start to say, okay, here's a true fact that we can build on. Unfortunately, otherwise, these papers, they're facts, but they're not necessarily in stone facts as much as we'd want them to be.
And when you mention papers, are you talking about in an academic setting or coming out of private companies or?
Mostly academia. So, a lot of the research, that we look at in a private company, we're looking at academic papers to get an idea of where we can go. We're using that basic research and trying to apply it. And so if that basic research, isn't sound or isn't replicable, it makes our job that much harder.
Yeah.
And I mean, as far as companies go in that space, there's a new one actually down in Vancouver. I forget what they just moved here, Abscess or something, but they're life sciences. You'll see a lot of those folks that are working with organisms. They may have a little side thing where they might have some ideas where they could use their technology for a renewable energy or a more sustainable product. But yeah, in this state, we don't have a lot. Does ABO still exist, the Algae Biomass Organization? So there used to be
like a conference in
DC. Yeah, there's the
once a
Algae
year.
Biomass Organization. There's probably one or two other industry type groups that would be your best bet on to see. That membership probably basically represents the people who are doing research in that area.
Yeah.
Okay, let's give a round of applause to Ellen, Chip, and Brian. Really appreciate the time you spent with us.